right, so here we go. So we're going to start with section 3.3, analyzing graphs and quadratic functions. And so here, a quadratic graph is a polynomial of degree 2. The degree means what's the highest power I see. Okay, so here we have f of x equals ax squared, so that makes it degree 2. If it was a to the 5th, it'd be degree 5. Plus b plus bx plus c, where a is not equal to 0. The standard, that should be form of the quadratic equation, looks like this. And so f of x equals ax plus x minus h squared plus k. Now, why is this the standard form? Well, because, what was it, in 2.5? I don't remember what when we did this one. Was it 2.5? We did like 10,002 different translations of functions, right? I think it was. And so when we did all those translations of functions, you know how to graph this already. I don't have to teach you how to graph this. You know how to graph this. It's here. I'm going to move it to here. I'm going to move it. So here I've already plugged in the negative. And so the vertex of my parabola is h because I moved over the reverse of that. So h and k, so that's where my vertex is. If a is negative, it opens downward. If a is positive, it opens upward. And so this is just this graph transformed by stretching it vertically, doing a vertical, horizontal translation and a vertical translation. Okay, so it's really all the same. So let me show you how to do this slowly with two of them. And then I will make notes on how to do the rest of the problems from there. All right, so let's do this. All right, so I'm just going to rewrite this as y equals 12x plus 22, just because that's what you're more used to. I'm going to label this as my x and this is my y. This will be my x, this will be my y. All right, so now how do I graph this? I need to put it into this form. Well, what is this form? Well, this form is done by completing the square. So as we completed the square multiple times last time, we're going to do that now to solve this problem. All right, so we're going to have y equals, I'm going to have 2x squared minus 12x. I'm going to close my parentheses and add 22. So this time, the first time when we did it, we put the 22 on the other side. This time we're going to create these spaces. I'm going to create a little space right here. I'm going to have plus something, right? So I'm creating this space right here. And this isn't a space, this is a negation. Okay? So the first thing I want to do, rewrite it this way, make space. Second thing I want to do is make this the factor on the x. So the second thing I want to do is take the x and make it clean as possible. So I'm going to pull out the 2. So I'll have 2x minus now 6x, and then I'll leave that space plus 22. All right, so what do I need to put in here? Well, what I need to put in here, let me kind of go up, is b over 2 squared. Well, here, b is negative 6. So minus 6 over 2 is minus 3. And if I square that, I'm going to get a 9. So I'm going to add a 9 here. But notice if I add 9 here, I need to minus 9 here. So basically, I'm going to, if I have 10 and I add 3 to it and then minus 3 to it, I still have 10, right? This is still 10. And so if I add a number, I need to minus a number if I'm working on the same side of the equation. However, this 9 will be multiplied by this 2. And so this 2 needs to come up here. So I need to multiply by the 2. So this will come here. And so let me just rewrite this a little bit cleaner. So I'll have 2. This is my perfect square of x minus 3 squared. 22 minus 18 will give us plus 4. And so here I've written it in standard form. Okay, so let me review that real quick with you, exactly what happened step by step. And then I'll have you guys try this one real quick. I'll kind of walk you step by step, and I'll have you give me each step. And that way it'll become clear to you. So the first thing we did is we took this and we we blocked in the 2x, just the x variable, 2x squared minus the 12x. So I just blocked that in with parentheses and left myself a space. The 22 I'm leaving on the outside. The next thing I did was pull out the 2. So I'm pulling out the 2 here, and I pull out the 2 here. And so here I get x squared, here I get this. I guess technically here is step 3. Step 3 is to put in b squared, b over 2 squared. So b over 2 is -3. -3 squared is 9. So I put that in here. Now, if I add it, I must subtract it to keep the equation equal, right, or balanced. So if I add it here, I'm going to subtract it, but I actually have 2 of them, so I need to subtract. I need to multiply that by 2. From here, I completed the square. It gives me x minus 3. So that's why we added in the 9. The 2 just drops down, and then 22 minus 18 is the 4. Okay, with all that information, we can now graph it. So where is my vertex? Well, my vertex is now at 3, 4. That's where my vertex is at. So I'll just count over 3. 1, 2, 3. Go up 4. 1, 2, 3, 4. And then I'm going to go over 1, and I'm going to go over 1 and then go my A. And so in this case, A is 2. Right? So my A here is 2. So I go up 2. And then I'll go over 1 and up my A, which is 2. And I kind of draw in my parabola. Okay. Let's do it again, and this time you guys are going to do it with me. We're going to do it step by step for this one. All right, so my very first step, I'll do this for you, is equal to, you're going to block out the first 2 and then leave the minus 10 here. Oops, I didn't leave myself that much room. And minus 10, okay. The second step here is to factor out whatever's on the x. So pull out a -3 and tell me what that is in chat. So go ahead and pull out a -3x for each one of these. I want you to do this step by step with me. So write x caret squared minus, and so it's the -3 from this one. No, give me the whole line. Give me the whole line. So it'd be -3 parentheses. So give me the whole thing in chat real quick. Give it a try. What would this line be if I factor out the -3? It'd be x squared, something, something, comma, something. Yes, so someone has it in chat. All right, so that's exactly what it is. It's x squared plus, oops, if I factor out a 3, it'd be 4x, comma, minus 10. All right. So here we have -3 minus 10. So the next thing I'll do, step 3, is add in my b squared. I didn't leave myself that much room. Let me rewrite this with a little bit more room. I just want to rewrite it with room. Giving myself more room. -9 times the 2. 2 here, and then we'll have y equals -3 x squared plus 4x space minus 10. Aha, now I have room. So here, b squared over, or b over 2 squared, well, so be 4 over 2, which is equal to 2. 2 squared is 4. I'm going to add a 4 here, and I'll add a 4 here, as someone already put in chat way earlier. All right, so then what's my last line? What's my last line here? That's my step 4 line then. But if I add a 4 in here, hold on, I need to multiply it by -3, okay? Because this is really -3 times the 4. And so if I add it here, I need to minus it here. Oops, sorry, I added a 4 and then I didn't. Minus a 4 times a -3, okay? Because I add it here, I minus it here. And then I need to multiply it by whatever what's out front. So what's the very last line here? Oops. Hi, Dokes. Let's see if anyone can put that together. What's the last part of this line? Super close. Someone did a very good job. Anyone else have an answer? That's right. Okay, so that kind of gets me where we're at. So I see where the trouble's at. So this is where the trouble's at. So here we have the -3. Here we perfected the square, so you guys get the x plus 2 squared. Pretty well. So here I have -10, -4 times a -3. So let me, so this would be -10, -4 times -3. Now this is the same thing as plus 12. And so when I do that, I'll get -3x plus 2 squared plus 12 will give me plus 2. And so here is what this is. And so it's just someone got it. Yeah, the v2. So here we have the 2 here. And now we have this. We have our vertex, which is at -2, +2. So -2 up 2 is our vertex. Or I go to the left I go left 2 and up 2, right? From before. And then I'm going to go over 1, and then I'm going to move my a. In this case, a is -3, right? So I'm going to move over 1, down my 3. And that's my points. And I think this is enough for you to graph it for your homework. I don't remember. Does this one have the graphing, or is it the other one has the graphing? Wait, I thought it was... Oh, you got it. Yeah. So here when we perfect the square, but b squared over 2 is 2. Yeah, no, it's easy to do. All right, so that's how you do these two. I'll leave that up for a second, then we'll go to the next page. Again, just a quite a review as I'm leaving this up for people to write it down. You're gonna take whatever your constant term is, move it out, factor out whatever's on your x squared. So factor that out. So here this becomes this becomes 1. I pull out -3 from 12, it becomes a 4. Then I take whatever's here, divide it by 2 and square it. I add that here, and then I minus it here. But when I minus it here, I need to pull in whatever factor this is, because I'm really taking away 12 here. And so I really need to add 12 here. But here I usually just leave it as I'm adding 4 times a -3. So I need a -4 times a -3. Figure it out, just complete the square, which is just b over squared x plus b over 2 squared. The a stays where it's at. And then I just simplify my term here. Once I have it here, I have moved to, this means go to the left by 2. So I went left 2. This means go up 2. So I went up 2. And this is my a. And so instead of going over 1, up 1, I'm going to go over and then up or down a. So in this case, it was 2. So I went over and up 2. And here I'm going to go over and down 3. Okay. I'm a bit confused on how you got the x plus 2. Okay, so here I've completed the square. If we go back to, hold on, I got those notes somewhere. Where did I put them? Whoop. Here you go. This will work. It's from another class, but it's the same song, same dance. So notice here, if I have x plus bx squared, this is just equal to x plus b over 2. And so here, squared. And so this is what you've seen. This is an older version of it, but it's fine. I had it available right there. And so here we'll have x squared plus 4 over 2, which is 2. 2 squared is 4. And so when I take this and convert it into its square, it's going to be x plus 2 squared. And notice we can check this. So it'd be this term divided by 2. And so that gives us 2. And so notice we check this with x times x gives us x squared. I get 2x plus 2x, which gives me 4x. And I get 2 times 2, which gives me 4. And so yes, this does turn into that. Okay. Yeah, you got it. I'm not worried about it. Okay, so let's do the next. All right. All right, I'm going to do this insanity. I think it's good for you to see me do this, but this is definitely in something I expect to be able to do, but not expect you to be able to, if that makes any sense. Remember the 3 things? Hold on, let me read this. Just for clarification, when you complete the square, you subtract the c value. Using graphing. Yes. I think what I'm going to do right now will put that as clear as possible. Because when we completed the square to solve it, we kicked the c over to the other side, and what we added to one side, we added to the other. But seeing how we're staying on the same side, we're going to add it and subtract it, because then I'm just adding a 0. Okay. So in one case here, I had something over here, so I'm going to add a 4 and add a 4, because that keeps this balanced. But if I'm staying on the same side, if I add a 4, I need a minus a 4. Because if you remember, if you think this is like a scale and that they're equally balanced, right? If I add 4 units to one side, I add 4 units to another side, that's the same, right? Here, if I add 4 units to that side, I might need to push up on the scale 4 units to keep it balanced. And so this is what we did last time. This is what we're doing this time. And technically, you can solve this. I can just say y equals a x squared plus bx. Leave my space, add a c. And so the next step I want to do is I'm going to take b over 2. So next thing, so if I was going to solve this, it would be a x squared b over a x plus c. And so this is now the technically b term, so it'll be b over a divided by 2, so it'll be 2, and I can square it. So what that is b squared over 4a squared. I'm going to minus b squared over 4a squared, and then multiply by the a like we did last time. That cancels out this a and this a. And so I have a x squared plus b over 2a, squared. No, let's just go back. Let's go back because I was on the wrong layer. B over 2a squared plus c minus b squared over 4a. And so notice, notice here, I can actually just write down an equation. I can just write down an equation because here I know the vertex for given any a is going to be minus b over 2a and then c minus b over 4a. And so this is my x coordinate, this is my coordinate, no matter what b, a, and c are. And so you can just solve this directly. Another way of doing this is, notice that this is my vertex, right? Here's my vertex, so be x. The x value of my vertex is this. And then the function value would be the y value, right? The y value. If I plug in what the x is, I'll pop out this as my y. And so you can find the max or min of any quadratic function because the vertex, the x value for the vertex will always occur here, right? I've solved it for you. I showed where it comes from, right? But here you can just believe it, right? You can just believe it, and I'll show us just believing it without actually crunching the numbers. And it makes it a little easier to graph these things. So, so here you can either use this for your vertex, or you can just use this and then plug it into the function. My suggestion is just remember the x occurs of the vertex at minus b over 2a. That's my suggestion. And then just plug that into whatever your function is and get out your answers. This is easier shown than explained, so let me show it to you. So, oops, let me see if I can still have that on the board. Right, so here I have x is minus b over 2a. So in this case, x is equal to, let me just write it right here. So b in this case is 4, right? So minus 4 over a in this case is 1. So 2 times 1. So that means the x coordinate of the vertex occurs at negative 2. Then if I want to find the y coordinate, I just plug in negative 2 into the function. So here, negative 2, so it'd be minus 2 squared plus 4 times minus 2. Well, if I crunch through that, that is 4 plus negative 8, so that'd be minus 4. So I know my vertex occurs at negative 2 minus 4. So let me explain how I got that one once again. The x coordinate of the vertex always occurs at this point. Why? I solved it for you. Do you need to follow the solving? No, it just kind of just shows where it comes from, right? Okay. You could just memorize this formula, or just have it, well, not memorize it since you guys are doing it all online, just have it next to you. So you just plug it in. Here's my a is 1, my b is 4. Plug it in, I get negative 2. Then whatever your x value is, find out what the function, just plug that into your function. So find f of 2, you get out your y value, and therefore you have your vertex. Once you know the vertex, I can just go over 1, 2, over 2, and then I go down 1, 2, 3, 4, right here. And then this, I go over and up a, and that will come here, over and up a, and that comes here, and then that roughly gives me my graph. Okay. We'll do the same thing here. Here, x is minus b over 2a. In this case, b is 1, so minus 1 over 2. This is negative 1, so 2 times negative 1, so negative 1 over 1. So this occurs at a half. Well, that's not super fun, but we can just plug it in. So f of a half equals minus 1/2 squared. Oops, that's a little hard to read. Let me rewrite that so it's easier to read. Minus 1/2 squared plus a half plus 2. We're going to come, this becomes minus a fourth. And so since this is a fourth, I'm just going to convert everything to a fourth. This is 2/4. This is plus 4/4, right? No, this is 8/4. That is 8/4. Right, 8/4. Convert everything to fourths. So I get 10 minus 1 will give me 9/4. So the vertex here is not super nice, right? It's just a half, 9/4. And so here I'm at a half, and then a little bit over here. And then I go over 1, down 1, then here, over 1, down 1, and that gives me my vertex, and I graph it in. Okay. So what we're doing here is we're just finding the vertex. And often if you want a formula, the vertex is all you want. All you want is the vertex. And so, and the minimum or the maximum of a function occurs at the vertex. So when you see word problems, 90% of a quadratic, for at least in these classes, 90% of the time you just want to know where the vertex at, because that's either the maximum for what you have and the minimum. So you know So you ignore the second part? Oh, no. I think, I guess I'm confused. Here, we found the vertex. The vertex gives us everything we need. In fact, we could rewrite this. Because I could write this as x plus 2 squared minus 4, right? Because I know what this is. I mean, if I solved it the other way, this is what you're going to get. And if I solve this one the other way, you're going to get minus 1, minus 1, and then we'll have x plus a half. Oops. X minus a half, squared, plus 9/4. Because once you know the vertex, you know all the data to put this in. Okay? So if I solve this by completing the square, this is what I would have gotten. If I solve this one by completing the square, this is what I would have gotten. But I wanted to show you that this is no longer necessary once you know this. Once you know x, this is x coordinate. Whatever you get for x, just plug it into your function. So I got -2 here, plug that in. I get 4. This is where my vertex is at. Here, my vertex always, the x value is here. Once I know at x, if I plug x in here, I can get my y, so that'll give me my second point, or the other part of my point, my y coordinate. It comes out here. Okay. I know this is a little bit strange and esoteric. Work a couple of problems that should come together. I'll open up the homework in a second, and then I'll ask you guys. Okay, so the first problem you wrote. Okay, let me see what it says. So for the first problem, so you mean problem, this one right here, Monique? Yes, okay. You wrote, oh, okay. I have -2 squared plus 4. Oh, so -2 squared is +4, right? Minus 4 times -2 is -8. 4 minus 8 is -4. Is that what you're talking about? And then here, I'm pulling in the 2. The 2 goes here for the x, and then here, this is my y. Somehow I think I'm missing your question. Okay, you're good to go. You're good to go. Okay. Notice here, once I get this half, the half is here and then there. Okay. All right. So let's do one word problem real quick, and then we'll briefly go over the homework, and then I'm going to ask kind of what you guys want me to prep for tomorrow. Saying I'm only half prepped for it. All right, so gas mileage of a car is based on the speed of a given vehicle, assuming many factors are constant, right? So I'm going to assume the weight of the car is constant. Like, you don't all of a sudden just add like 10 people to the car because that matters for gas mileage. I'm going to assume the car is on an even road. I assume friction's constant. I assume the humidity is constant. It's just a whole bunch of things. So, the following is the miles per gallon for a given speed of a car. So, at a given speed so if a car is traveling at a speed of s, the amount from 14 to 70 miles, the miles per gallon you get is given by this function, right? It's kind of a complicated function. And so I want to know what is the best miles per gallon this car can achieve at what speed. So before we do this algebraically, all right, so let's just graph this puppy. And so I have minus 1/28 x squared. I guess I don't need this parenthesis if it knows to do that. Good. Plus 3s minus 31. Oh, hold on. Let's keep it all as X so the program knows what we're doing. Did it graph it? Why you not graph? Oh, it did. It's just way the crap over here. Woohoo! All right, so here we can look at this, right? And so between 17 miles and 70 miles, we have our miles per gallon here. And so we want the most miles I can get per gallon. And so it's going to look like, vaguely, if I zoom in, it looks like 32 and 42. That looks like the vertex, right? And so it doesn't hurt to graph these quickly and just say, oh, that's probably what it is, right? So let's do it by hand and see what we get. So the best mascot, so from what we're reading here, it'll be at 42. Our speed will be 42 because that's what our X is. And then we'll get 32 miles per gallon. So let's solve it by hand. So to solve this by hand, we're going to just say S. And so S is like our X. So the vertex for that would be at minus B over 2A. Well, in this case, B is 3. So it'll be minus 3 over 2 times 1/28. 1/28. All right, let's see if I can do this in my head. I know I can do this. So the negatives cancel each other, so that's for okay. I can divide out a 2, so it'd be 3 over 14, or 1 over 14. Multiply 14 up top will give me 42. Yeah, so this is 42. You go ahead and chunk it through a calculator here. So get 42. So M of 42. This you're definitely going to want to chunk through a calculator. So we just plug it into this function. 42 squared plus 3 times 42 minus 31. You chunk that through a calculator, you're going to get 32. Okay, so 32 miles per gallon is the best. This car can achieve at the speed of 42 miles per hour. So 90% of times when you're solving these, you just want the vertex. What's the best? And so that'll be the min or the max. Okay.